So hello everyone, welcome to my channel Quantum Ideas. So today I'll talk about some problems related to linear and exponential growth. Okay, so if you are new to this channel, please like, share and subscribe. I'll be posting few sad content like this on my upcoming videos. Okay, so let's get started. The topic that I choose is linear versus exponential growth. So there will be few questions related to it. Let's get started and let's see number one. So it has given, if the initial population of rats was 20 and grew to 25 after the second year, which of the following function best models the population of rats p with respect to the number of years t if the population growth of rats is considered to be exponential? So main point to be noted is that it's exponential growth. So the equation for the exponential growth is like this. So any function y can be expressed as let's say c x to the power t. Okay, so let's say y is any function, that is, let's say population here. Okay, we have given, and what is this c? Actually this c is the initial value of the, let's say, population. Okay, what is this x is actually growth factor or decay factor, we can say. Okay, so this is simply growth factor, we can say, and this t is actually time. So let's see, and further we can also write this as y is equals to c, right, 1 plus minus r percent to the power t. We can simply write this also. Okay, this will be best way to write this equation simply. So what we can say here is that the growth of the rat is considered to be exponential. Since the growth is exponential, simply the answer can be linear. This is the linear equation, right? Y equal to mx plus c type, right? So this can be our answer, and this is quadratic, and this can't also be our answer. So answer should be B or C, right? Because A is linear, D is quadratic. So let's go and find the solution. So what it's saying is that the initial population rat was 20 and grew to 25, right, in the second year. That means the population has increased, right? Population has increased means it has exponential growth. That means we can write this equation as P equals to, what is C is the initial value of the population was 20, and there's I should plug like this bracket, and the population has increased means 1 growth rate, 1 plus growth rate, that is r percent, right?
Right.
And then there is the time. So we have to find this r percent. R percent is the growth rate. So how to find the growth rate? That is given by percentage change. Okay, that r percent can be found by using percentage change formula, that is new value minus old value divided by old value into 100%. So what is the new value of the population is 25. What is the old value? That is 20 divided by old value is 20 into 100%. So what you get here is simply 5 over 20 into 100%. So 0025, that is 25%. So that is 21 plus growth rate is 25% to the power t. If you convert this into decimal, you can get 21 plus 0.25 to the power t. This is simply 21 1 point, sorry, 1.25 to the power t. So this is your answer, 21.25 to the power t. So your answer is B. Okay, you can do in that way. If the question was given like it's like here was 25, say here was 20, that means this is exponential decay, population is decreasing, you have to use here minus. Okay, in the formula here minus instead of plus. Okay, so let's go to next question. Okay, what is it saying? Let's say if the population of pandas was 100 and grew to 125 after the first year. Okay, which of the following function best models the population of pandas p with respect to the number of years t if the population growth of pandas is considered to be linear? So again we have to find the equation, and it is saying that the population growth is actually linear. So we all already know what is linear, right? Linear is in the form of y equals to mx plus c, or in term of population will be equals some m t plus some numbers, right? Like this. You can see here, you can answer directly even without knowing the concept here. Let's see, this is the linear equation, right? This is the linear, yeah, that's true. This is exponential, so this can be answer because the question says it's a linear growth. So this is also linear, and this is also, this is quadratic, this can be answer. So these three cannot be and our answer, so our answer is obviously A. But how we can also find out? So we know that y equals to mx plus is the linear equation. Okay, so we have to find out. So y is actually our population p, we know that. Okay, and there is slope of the line, and this t is the time, plus what is c? C is the initial value of the population. What is the initial value of the population? Initial value was 100. So this is okay, I think it's 100. Okay, here some mistake, so there will be 10 extra should be here. Okay, that's the mistake. So that should be 100. Okay, so p is equals to what we have? Slope. What is the slope? We have to know the formula. So slope is simply like, we know that y2 minus y1 over x2 minus x1. So here our function y is population of the pandas and x is the time, right? So time. So what you can say? We can say p2 minus p1 by time period. So what is the p2? That is 125 minus what is p1? That is 100, right? Population 1 and time is in 1 years. So simply your answer is 25. So rate of change is 25 per year. So 25 t plus 100 is our answer, guys. So A is our answer. So let's move to number 3. Suppose a certain substance decays at the rate of 0.5% per hour. So there is a rate. So rate is 0.5% per hour. Okay, and you can also allow it to use calculator in this DSAT. Okay, digital SAT format. Okay, so a given rate is also there for 1 hour. Which of the following best represents the exponential model? So you can see here all of them are exponential, right? So we know that p is equal to, let's say there is 100 in every, so we have 100 and there is a decays, so there is exponential decay, means what we know, 1 minus r% to the power t, right? So 100 1 minus what is the rate of decay? That is 0.5% per hour. Okay, that is the time. So this is 100, we can write 1 minus 0.5, just divide it by 100, you get 0.005, okay, to the power t. So just subtract it from 1. So 1 minus 0.005, you will get 0.995 to the power t. So the answer must be D. Okay, let's go to number 4. Which scatter plot shows the strongest positive association between x and y? Okay, we have to find the strongest positive association between x and y. Okay, so what you have to check is that you have to just make a line simply to check, and there is a, this is actually, this point are the graph plot for the point x y. Okay, these are like data points x comma y. For example, x could be like, let's say your age, and y could be your blood pressure, like systolic blood pressure. Okay, this is the graph between, let's say, age and blood pressure. Okay, for one person, for second person, for third person, or where okay, different data points, let's say. So we have different data point, and if you draw a line like this, okay, okay, and you can see here the points are the few this data points are scattered from this line, right? And if you see here, if you cannot draw a line here, okay, because the data are so random, so there is actually no association. And if you see here, if you make a straight line, you can see that most of the data points fall on the line. Okay, and also if you make another line here, you can also see that few data points stick together at the line, but few are away from the line. That means, so strongest association between x and y is shown by number C. Why? Because most of the data are linear. Okay, they are linearly modeled. Okay, so you can see here they are linearly model. That means they have strongest positive association. Okay, and if you see here, okay, sorry, if you see here, there is also not strong, but there is also positive, but this is negative because line, the slope of the line is going down, and there is actually no association because we cannot make any relation line there. Okay, so let's go to next question. So let's see number 5. A certain country in Europe has population of 4.5 million people. The population is growing in the exponential model. Again, exponential model. So it has also provided us with this equation. P is equal to, this is million people. Okay, 4.5 million people, and there is given us the decay factor. Okay, this is the decay factor, and where T is in years. What is the growth rate of the population? We have to find the growth rate. So P is equals to, we have 45 million, and this is 1.0070. we know that, right? We can just use, we have to find the rate, growth rate, so we have to convert this into percentage. Okay, this thing, so we can also write this as 1 plus 0.007 to the power t. Now what we can do is, so we have to convert this into percentages, multiply it by 100%. So what we get, okay, you can use calculator. 1 plus, so 0.007 into 100. So this is simply 0.7% to the power t. So our exponential growth rate is 0.7%. is your answer. D is your correct answer. So let's go to number 6. Each year the value of an investment increases by 0.9% of its value the previous year. Which of the following function best models how the value of the investment changes over time? A is decreasing exponential, B is decreasing linear, C is increasing exponential, D is increasing linear. So okay, again let me say that in a linear model, something will actually change constantly. Okay, actually linear change is a constant change, or linear decay is constant decrease, or linear linear growth is constant increase. So if the value something is always increased by 20, right? Like say I have 20 rupees today, and tomorrow I have 40 rupees, and after next day I have, let's say, 60 rupees. That means my money is increasing by 20. So this is said to be linear growth. Okay, if it's decreasing by 20 and 20 per day, it is linear decay. But here see what is say that, let's say I have my investment, okay, and every year what is say that the value of the investment is increasing by 49%. Okay, by previous year, means let's say I have this investment this year, and next year it is increasing by 0.49%, and again the total money, that is increased value of investment, is again increased next year by 0.49%. Okay, and again I have some money here. Okay, there is additional money over investment, and again in the next year the total value of this investment is again increased by 0.49%. You have to understand that the growth is actually happening in term of percentage of the total investment plus its what increased value. That means what is happening, it is growing in term of exponential. Okay, you can see here each year the value of investment increased by 49% of its value the previous year. Which of the following function based model how the value okay, this cannot be linear because it is happening in term of percentage and it's happening per year. Yeah, okay, and there is no decreasing, right? It is, question is saying increases, so there is no decreasing, cannot be answer. So there is only one answer, that is increasing exponential. Okay guys, so guys, thank you for watching. If you like this video,